Hey everyone, how's it going? Welcome to the stream. Running a little bit later tonight. This is going to be a shorter stream. Been dealing with coronavirus preparations, I think, like everybody else has. So yeah, just been a little busy. But yeah, I just decided to squeeze in a little stream for tonight. We'll see how far I can get. So, oh hey Jono, how's it going? Hey, by the way, thanks for the sub, man. So I know you weren't there last stream, but I don't know if you got a chance to watch all of the VOD, but I actually ended up implementing the your recommendation for the this thing here, the wait for debugger attach, which I'm using right here. So rather than put an infinite loop, decided to put that in there. It's been working really well. Yeah, yeah, we're okay. I mean, lots of precautionary measures are being taken here in Canada. So yeah. Oh, just a sec. Hey, sorry about that. Oh yeah, thanks. So yeah, so basically the next thing that I'm hoping to get done is the showing of the call stack. So there's a bit of work to do there. I started looking at what I have to do. I wrote here, add symbols for function names, integrate call stack tracking code, display call stack as function names when available or address otherwise. So the first thing is this here. So adding symbols for function names. We currently don't have such a thing. There's no concept of, you know, what function am I currently in right now. So I've been looking at, basically we're gonna have to like parse this out of the stabs information again, you know, the symbol table stuff, the debug info. So I was looking at this section on procedures, and it says all of the following stabs normally use the nfun symbol type. So nfun, like here's an example. You know, the following example shows a stab for a function main which returns type number 1. I don't know where it says that. Type number, oh, F1. Yeah, so that's, where did I see that? F over here. A function is represented by an F symbol descriptor for a global extern function and lowercase f for a static local function. The one, I'm not sure what it means yet. And it says the main specified for the value, the main specified for the values, this one here, is a reference to an assembler label, which is used to fill in the start address of the function. So this is sort of like the friendly name, I guess. It says this means it's an n_fun type. So if we go back to these types here in my stabs, sorry, the RST parser here. So I have these types here. So like we could add here, and what would we say was 36? So I probably should put the decimal value. I don't know why I haven't been doing that. Or is it the decimal value? Let me see. I don't even remember. 68. Yeah, I haven't been. So 44 is 68. I should totally put the decimal number. I'll just do this. And then 84, because we know when we're looking in the file, it's nice to actually be able to read it. This is 132. And then nfun is, what were we saying again? It was from the file here, 36. And then 36 would be, whoops, 24. I'm going to put the hex value because I think it's referred to by hex in a few different places. All right. Now it says here, it actually says the stab representing a procedure is located immediately following the code of the procedure. This stab is in turn directly followed by a group of other stabs describing elements of the procedure. So basically, rather than be like the very first thing described, like it's not put before a function is described, it's put afterwards. And indeed, it's what I saw here. I was looking at main. So like, for example, this is main, right? This is the label itself at this specific address. And this is important because I'm going to need to basically know this. I think what I'm going to have to do is while I'm parsing, I'm going to have to pick up on these labels and store their addresses, right? These are symbols basically. And then, you know, parsing all of this stuff, all of these functions here, sorry, all of this code, somehow I'm thinking that like, I don't know if I need to I'm trying to think, like right now what I'm doing is for every, you know, instruction address, I'm storing the, you know, mapping to the source in line. I don't know if I also need to store what function that's part of. And the reason why I don't know that is it's possible that we don't need to do that, since I have a call stack, and I as long as I know the address of the like entry function, you know, like the address of the entry that we, like for example, if when we enter main, it'll be 0AD2. And I can always reference the current call stack and say, well, what function am I in? It's the one, you know, at 0AD2, this label here. So I think I can get away with that. And then the idea would be that we go through here, I store this label, we parse, and we look now for the stab, which one did we say it was? 36. So actually main is not a great example because it's kind of long, but if we look for comma 36 comma, okay, so this is the end of main. So it's all of this code above here, and it stops here. So this is saying, okay, you know, there is a function called main, and it's at label main. So when I see this, I can enter this as, this is a function. And it's at that label, and then this is useful y. I guess maybe it's useful because of this name here. Let me see what other 36s look like. Yeah, not super useful because these names are all mangled, right? Of course, I'm going to have to demangle them. Like this one here is the max function. I think this is because it's a template that it looks like this. Let me see. What are we looking at here? Okay, so there's the label. So this is basically, this actually is a good example because it fits on one screen. So, okay. So for this specific label, we are at source base.h, I think line 132. So let's go look. If I, whoops, not there. If I go to base.h here, no, okay, it's not line 132. This is just a source line. Oh, here you go. Stab D 6899. So there we go. So this is it is a template. Let me put that on the side here. All right, and let's go back to our RST file. Okay. So this is a namespace std. I put that in there, so I think that's what this st apparently would stand for. Not extremely helpful. Maybe not. TLS. Okay, so this is an instantiation actually of max, where the type is probably S0 probably stands for, like, you know, signed integer or something like that. So it's probably an instantiation where I call it on two signed integers, and it probably returns a signed type. I don't know. Anyway, it's mangled. I'd need to demangle it using some GCC demangling thing. Let me see if I can just quickly find that. GCC function demangle. I wonder if there's like an online one. That'd be cool. Oh, there you go. So this means that we can totally do this ourselves, and that's what we're going to do. I'm not sure about this extra underscore. Probably the deal there is actually not to use this name, but rather to use this one. You see there's an extra underscore for the label itself. So that's, I think, maybe one of the points to saying this. Oh, this is a function. This is its actual name, you know. So we can have some function information. And maybe this extra stuff we'll store about the function afterwards. So like if we took this name instead, it should give us the proper, there you go. So that's an instantiation of this function. So yeah, so I guess that's useful. I mean, we can pretty much always just remove one underscore from the label, but it would be more correct to do it this way, to look for these 36s. If we look for another example, this is a similar thing for min, right? This looks like it'll give us the same deal. Yeah. Keep looking. Just want to see. So here's a more interesting one, I suppose. This one looks like it's got namespaces in there. There we go. Void Vectrexy : printf with the int for an integer. That's the template parameter. Accepts a const star and a single int in this case. So definitely we want to do this demangling. What else? So let me think. So let's say we store symbols. Now we can also store functions. So when we are about to jump into a function, we know the target address to which we're jumping into, where we're calling into. That we should be able to look it up and find the function information for it. I think that makes sense. And the only reason I need to track the label itself is just to know what address it's at. Because here this just says there is a function. In this case, oh yeah, this is what I was saying about lowercase f, right? So I still don't know what the 2 is about. It would be nice to know. But anyway, might be interesting to know if it's a static function or not. In this case, it's considering it a local or static function, probably because it's a template, so it instantiates it, right? So it's not like a global function. It's really something that's stamped into this object file, so it considers it a local or a static function. Not that I really care that much, but anyway. And it's saying this is the label, so I need to have known where this label was, so I will have to store the label itself along with the address here. So I will detect those and add those as symbols, which is something I already do, right, for something else. Let me see here. I go to my debug symbols. Yes, I was already doing it for main. You see here, I was actually looking specifically for main, right? Which is cool. So it's going to be similar to a main regex. Whoops. It's going to be similar to this, except rather than look specifically for the name main, like we're doing here, we're going to pretty much look for the same thing except underscore something with a colon. And when we find that, then we say, okay, we found a symbol. I mean, I don't know. Should I call them symbols? Should I call them names? I don't know. Like labels, I could call these labels. I'll call them symbols for now, for lack of a better name, because they're sort of symbols at this address. That's a symbol. It's really a label. I don't know. Thing is, I'm going to get a lot of labels, and that's the only thing that kind of sucks. But, and I suppose I don't really need them after I'm done parsing. So another option, I suppose, would be collect labels, but don't store them. And then only when I see, yeah, maybe that's what I'll do. Collect labels locally while parsing. Because I suspect that while I parse a single file, I should see the labels and function definitions for that one file. There should not be like cross-file symbols here, I think, which would make sense because everything is, that's how C++ works in C, because it includes all its headers and everything, so it needs to see everything. It needs to see at least prototypes for functions, right? Yeah, actually, do I have an example with a prototype? That would actually answer that question for me. If I look, yeah, I totally do. So here in main, like here, bias play sound, right? This is defined somewhere else, but it's declared. So if I look for play sound, will I find it in here? So there's a jump to it, but it probably is just jumping to it. Right. So yeah, that's fine. I won't have to worry about that because it, you know, this is not part of what I need to parse. Basically, if the function is defined in the CPP or header files that it includes, I will see the definition in here and I'll be able to add that symbol. So yeah, I think that's what we're going to do. What we'll do is, while we're parsing, I'll just write a little note for myself here. Store labels we see along the way in a local map or something. And when we see a nfun stab, look for it in labels to get its address, then add a function info to debug symbols. Yeah, I think that's what we're going to do. Okay, now actually, before I do that, I was just thinking I don't really need to start with that right away, because there are also functions for which we're going to call into that I don't have a name for, and I need to display their address. So actually I should start with that, just showing addresses. And then after that, when I have the names, I can put that in there. So I was also thinking about that earlier today. So let's say I move this up, integrate call stack tracking code. One of the things about this was I was thinking about how, like, oh no, okay, now that was for doing step over and step out. Yeah, okay, I can deal with that later. All right, so call stack tracking. So that's the code I've added, that I added recently to my regular debugger. So if we look in here, I have this class called call stack, right? Okay, so here we go. So this is my stack frame, my call stack. This is all that stuff I did to get this working, and basically the idea is I'm going to do something very similar. Yeah, this is what it was. I have this post op update call stack function, which is going to be extremely similar. It makes me feel like I need to extract this, most likely. Yeah, that would make sense. This is probably where we're going to start seeing me sharing more code between my debuggers. So this is definitely something I need to share, because basically every time we execute an instruction, I run this post-op update call stack with a snapshot of the registers as they were before we executed the instruction. So this is my way of detecting when the call stack changes. You know, did we call something? Did we return from something? This is the function that updates the call stack. So I definitely need this. So yeah, so that's that. And I want to also look for, so that's here. The other thing is this is the code that actually reads the call stack. Now this was for implementing next. I'm gonna do something not exactly the same, it's something inspired by this for when we do it in our case. In our case, it's just a little bit different because we are not executing instructions, we're executing statements. That's one way to think about it, right? We're executing like line by line. And we basically want to run all the statements for a line, for a given line, when we step. And that's one of the tricky things here is that normally in a cluster of instructions, the last one will be the jump for the line. You know what I mean? Like if we have, let's say, we're going to call a function and we're passing it arguments, the first few instructions will be like pushing those arguments on the stack. And then there's a call or a jump, you know, like a branch subroutine. And then sometimes there's like popping the return value off the stack. And that cluster is like one statement, it's the call. And I will have to do some work to basically when you do, let's say, F11 to step, I'm not on the instruction that will step. I'm going to have to sort of like keep executing instructions until either I actually do make a call, so I do make a jump, or I don't, in which case F11 behaves like F10, which means step into becomes the same thing as step over. So it's a little bit more tricky, But so it's not going to look exactly like this. I don't think I'll be able to do conditional breakpoints and stuff like I was doing here, but I'm not sure. We'll see. Same thing for finish, which is basically step out. I'm going to have to think about how to do that. Okay. Then, and that's it. So yeah, really, and printing of the call stack, I mean, this is custom for my debugger here. We're going to do something similar to populate the frames for the debug adapter for the protocol. So that too, I won't be copying directly. So mainly it's this function here, right here. So I need something here. Let me take a look. I actually was wondering if I should put this logic in the call stack class, you know, since it modifies its state and all. Yeah. I don't know. Let me think. Would it make sense? Or maybe it would have to be like a separate function outside of here, you know? So I have a call stack. I want to update it. Yeah, I don't feel like it should be in there. This is more like just a data structure that represents a call stack. It should be something else. And either it's in this file or it's in some kind of debug util, which is sort of where I was leaning in my mind for this. I don't really have one of those now yet. Let me see. Yeah, I don't have one yet. Okay, so let's do that. Let me go in here. Call it debugger util. And similarly, we'll go into the source here. Debugger util. Just gonna regen cmake here. That should bring in those files. There we go. That's debugger util. Okay. So something like this. And what we'll do is we'll take the call stack by reference along with these CPU registers. Rename that. This I do not have access to, so we're going to have to pass in the CPU, in the memory bus. Oh, and then there's get call op return address. So that's another thing to move. In fact, this will stay in an anonymous namespace here. Emulator memory bus. Okay, that's good. Okay, so yeah, so we were saying that we're going to need these registers as they are now. So here I have the CPU registers pre-op. I wonder if I could just pass the current registers. And I also need the memory bus. And I need the CPU. So maybe I'll just pass CPU and memory bus as well. That's the only thing with these kind of helpers, right? Is that you end up having to pass lots of parameters. Why was I grabbing this here? I guess to access m_call stack. So this will become a ref in this case. Okay, so let's see. That'll be CPU. And the memory bus. So this renames to CPU. This gets renamed to memory bus. Oh, and these are pointers for me right now. I'll make them, excuse me, I'll make these reference types. Same for my memory bus. Yeah. Oh, and this would be call stack. Cool. So this looks like it should compile. In which case we should be able to move this in there and forward declare some stuff. Perfect. So this means that my normal debugger, I can get rid of this code. Debugger util. I think I'm going to rename this. Why did I call it again? Oh, yes, because after an op, after we execute an op, I'll leave it like this. Call after every update call stack. So debug, oh yeah, I gotta include that guy here. And we should be able to get rid of all this. Okay. Make sure this all builds. Oh, okay. So you see, I have a compile error that's saying in callstack.h there's an optional is not defined, and sure enough, I'm missing the optional include. The reason this happened is because I don't have a CPP file for callstack, and so I don't have a way to like validate this. And really, I should have a CPP for every single header file. I haven't really been good about that. But that's one of the reasons why it's a good idea to do that, because even if it's an empty CPP, even if all it does is include its matching header, it'll guarantee that your header is self-sufficient, that it has all the includes that it's supposed to have. And the only reason this was working before was it depended on the inclusion order. I would have included callstack.h somewhere where above it was another include or something that included optional, and that's why this was hidden, this problem. Okay, so now it's building again. So what I should do actually is make sure this runs properly. Let me just see, how did I set this up? Right, so if we don't launch with DAP, and rather just launch with this directly. Just want to make sure my callstack stuff is still working after the refactor. So backtrace, yeah, that looks good. And if we say like next, if we say finish, we should be out of that function, which is wait recal. Yeah, exactly. So you see we're no longer in wait recal. But see, we're inside a BIOS routine for which I have no name, no label. We're in the BIOS show select game screen. And there we go. So everything looks like it's good. Yeah. Good. So that's working. Now we go back to the fact that we have this means we could start adding the call stack. So it's just a bunch more copy paste to do here. So we go to DAP debugger, add that in here. Okay, so let's add it right there. Oh, I guess I don't have a reset yet. No, I do. It's just not implemented. Let us implement this. All right. Hey, how's it going, Blue Dragon? Long time no see. At least on stream. What's UG? Ah, yes. Same for me. Same for us. We, in fact, they didn't just ban travel, but they banned going to work almost. We're extremely strongly urged to work from home. So unless you have a really good reason, just you just gotta stay put and work from home. My programming days might resemble this right here for the foreseeable future. Yeah. So I've been talking to my buddies because I'm no longer in games, and where I work now, working from home is way easier to do. We're mainly programmers. We mainly work on stuff that's on PC, so it's not so bad to work remotely. But yeah, in games, it's not the same story, right? It's a lot more challenging. You have a lot more interactions with different disciplines, with artists, level designers, a lot more interaction. So it's a lot more challenging for games. Yeah. Yeah, I guess it's true. You guys tend to work on in Unity, right? So, and I guess you said VR, so you're equipped to actually do your VR dev. That's cool. But we are certainly living through a changing epoch. That's a good way to put it. It's nuts. Like, I remember a few years ago, like trying to convince people at work that we need to do more to support remote work, that we could actually hire better people if we allow ourselves to do that. We can make people happier. How often, do you find yourself wanting to, I don't know, step out and go to a doctor's appointment, a dentist, the bank, or even do some groceries in the middle of the day when, you're not as busy or it's not as full. But if you're forced to be in the office, it's like you're always stuck going at night or on weekends. There's just so many good things about working from home, and offering that as an option just makes a lot of sense, right? But a lot of companies push back on it. But now, those who embraced it are in a good position right now to let their workforce go home and not lose too much in terms of productivity. And those who haven't embraced it are scrambling. My producer friend who left the games life to go work at the bank is living that life and has been reaping those exact rewards. Yeah, a ton of flexibility. Exactly. I guess I'm one of those people. The thing is, though, I actually like going into work. I like being around people, and there's benefits, right, to being at work. But I also love the flexibility that I can choose to work from home. Jono, you're saying, yeah, we have the technology to be productive from anywhere. Absolutely. Yeah. Yeah, we're very fortunate in our industry. This can be done for us. I feel really bad for all the people out there whose jobs just, you know, don't allow it, right? There's so many jobs that you just cannot work from remote, especially people in the health sector. I was just talking about that with my wife. Like, you know, what are nurses supposed to do? Like, they're shutting down schools, and doctors and nurses have kids, right? And if they're not in school, where are they? If they're not in school or daycare, then they have to be home with them, but they have to be at the hospital to help people. And so it's a big mess right now. So Jono, you're out there in Australia, right? How are things going over there? Your wife is a doctor on top of that. Everyone knows Tom Hanks and his wife are in Australia with the virus. Yeah. You're saying you think that it's making it a lot more real? The fact that Tom Hanks got it, is that what you mean? Right. Yeah. How famous you are. Exactly. Yeah. So in Canada, it's not too bad either. I think everyone's sort of learning from the, I don't want to say mistakes, but like from the unfortunate situation in places like Italy right now, and certain areas of China, of course, where they were not quick enough to like, shut down schools and public places and events. We're still I think at a point where, at least that's what they're saying, right? They're saying that in Canada, they can slow down. If they can slow down the spread, then there's a chance for the health sector to be able to, for healthcare to be able to do its job. Otherwise, they'll just get overwhelmed, which is apparently what's happening in Italy right now. I have family there, so that really sucks. I don't think anyone's sick yet, but it's not great. Yeah. Anyway, don't want to keep it too down here. I think let's try to be positive, and everyone's rallying together. I do like seeing that. I like seeing that people are really trying, embracing this. Like let's stop this thing and let's stay home and make it work, and let's like try to help each other out. And we'll get through this, But I have to say, when I went grocery shopping today, and like the aisles are like half empty. I mean, not of people, lots of people, but the shelves are empty. There's like no cans, there's no toilet paper, there's like nothing. It's crazy. It looks almost like, a scene out of those movies, right? Or like in in Walking Dead, when they walk into an abandoned store where everything's been raided. I mean, we're not quite there yet, but yeah. Yeah, let's do some C++. Okay, so basically I just need to do the same thing I'm doing over here. So this is an execute instruction. So what I did is put this as make scoped exit on exit. I did this because there are exceptions that can be thrown, and I'm probably going to have to do the same thing here. Right now I'm completely ignoring the fact that exceptions can be thrown by execute instruction, which is not a great idea. Oh no, actually I'm not ignoring it. Here's my try catch. But I'm not doing anything with it just yet. But I think I will do the same thing I was doing here. So in my case, it's actually really important not to miss the updating of the call stack if an exception is thrown. So let's do this. I'll put it inside the try. Oh, actually, yeah, I'm returning in there. Okay. Yeah, supply chains. Do I not have a memory bus? Oh, really? Yeah, I need a memory bus. Get it from the emulator. That's right. Include debugger util. Okay, next we need pre-op registers, so that's just grabbing it right before like this. So this should get us at least updating the call stack when we make calls and all that, which is great. So now, with that in mind, I should be able to at least show the addresses of the calls. So let's see if we can do that. So somewhere in here, this is scopes. That's not it. Where was it again? Oh, here. The stack trace request. Just give me a sec. Okay. Yeah, I won't be able to stream much longer. It is getting late, but let me see if I could at least put something in this call stack response. And if I at least see addresses, we're much closer. So this is a stack frame. So what does this look like again? We got the column, the end column, end line, ID. Oh yes, I need to set that. And the line within the file of the frame. Get from the call stack, yeah. So here I'm going to put an address when I don't have a name. Source here. So source is this thing here. I think this is optional, right? Yes. So if I don't have source, I don't put that here. Typically a method name. Okay. All right. So let's see. How do we do this? It's a stack frames push. I suppose we push it from top in. That would make sense. Yeah, I was just thinking that for this to work, the idea behind the source thing here is so that when you double click the stack, it goes to the source and line that we're at right there. So that means I think we should be able to do that with the address of the callee location. Yes. Yes, actually we should be able to do this. Maybe I don't need to track functions now that I think about it. Yeah, maybe I'm way off on that one. See, I'm kind of glad I started with this instead of starting to work on capturing functions. I might not need to do that. Okay, let's see. So what we do, okay, we're not going to really do this here. We're going to grab our call stack. And in fact, I have the display code that we have is going to be somewhat similar. Print call stack. So I'm just going to grab this. We're going to base ourselves off of this. So here I'm going in reverse, which, yeah, because I push, so the last frame is what we want to see at the top. So it's the same idea. What am I doing here? Oh yes, I was specially handling the top frame. I don't need to do that here for our case. It's going to be simpler. All right, so given that I have the frame, there's the current address. Oh no, maybe I do need to do something special. The current address is where I am within, oh yes, that's right. Current address is where I am within the current frame. Frame address, what is that again? Address of the first instruction of this frame's function. Do I need that? I don't think so. I think I just need the current address. Now, what we do is like this. We create a DAP source, an optional DAP source, just in case it's not there. right? Stack trace response. Yeah, actually this is a DAP optional, so we'll do the same thing. Source, okay, frame. So column is always going to be 1. Okay, frame. So frame ID has to be something unique. I think what I'm going to do for that is I'm just going to use iter. I could use anything really. I guess I could say frame address in that case. That's a UN16T. This has to be some kind of integer. I think that should work. Bit unsure why. Okay, so source is actually a source file. It's not a source in line, is it? Okay, so I thought source had the line number in it. I see. Okay. So, all right. Get the current address. So maybe what we'll do is something like this. If I is 0, just do this. Otherwise, do this. So now I don't need this. And then we can go to our symbol, the debug symbols. Get source location for the current address. If we get one, then we should be able to set source dot source name to location file, frame.line to location line. I think source needs more. There's also path here. Yeah. So we did that, right? When we're doing stepping and stuff, there's a place where we handled getting the path properly. Where did I do that again? Oh yeah, it was here actually. Yeah, this is actually a total hack, right? I'm going to keep the total hack for now. And then we'll fix this later. Okay. And in fact, I was doing this here, source name yeah, Okay, great. Excuse me. And then frame.source will be equal to source. So if we set it, it'll get something. If not, it'll just be an optional source that has nothing in it, right? What else? Actually, I suppose I could just do this. It doesn't need to be optional. If we set it, it's set, otherwise it's not set. So that's better. Okay, now anything else I need to set on the frame? We have the ID set, the column, the ID, the line, and the source. We have, and then we got to push back the frame like this. So I actually think that's it. Let's see if this works. All right, built without errors. So, all right, let's see what happens. Let's just go for gold, right? So we come here in VS Code, we hit a 5. That's going to launch Vectrexy. It is waiting for me to attach, so that's fine. I'm just gonna delete a bunch of breakpoints. I'd like to put one in here because I'm very curious to see how this behaves. So let's attach to Vectrexy. So it's parsing our ST files. It always takes a little while, and boom, we hit our breakpoint here. So we are being asked now, what does it look like right here? Our call stack, it has 2 frames on it. That's great. So the ID is just some value 2770. It's going to be, what did I say? It was the frame address. Yeah, so it's always unique. So I is 0, so we're going to be getting the current address is where the PC is. Hopefully we do have a symbol there. So we go and we set the path, all of this here. So what does this look like? Main.cpp and the full path. The source is set. The line is 34. Great. We push that back. Next one. The next one does not have. But you know what? We should set a name in that case. Right? If we don't have that's right. If we don't have a path, then we set a name. So at least we say source.name is equal to, and let's put the address. All right. And then I need to create a source in that case. Is that correct? Or is it? Oh no, it's frame.name. Okay, frame.name, right. Oh, that's what I was saying. It's usually the name of the function. Yes, so I do need the function name. Okay, so we will do that function name label thing I was talking about after all. But here, frame.name is going to be the address. I guess I could do that here as well. Okay, so how do I get, I want to show a hex version of the address. So we'll do a formatted string, the usual 0x. What have I been doing again? It's oh no, I've been actually doing this a bit differently. I've been using the $sign. I wonder if I should do it that way rather than 0x. I don't know. I've been doing this $sign %04x like this for addresses. It'll look less the way Visual Studio is used to showing things, but that is sort of how we talk about addresses in these old systems. Not sure. Otherwise, it'll be this here like that. And the address is cur address. So maybe what we do is like that here. I'll do like this here, and then I'll just say no, you know what? Just leave it like that. In fact, I don't need to do this here. It has nothing to do with whether there's a source location or not. But it does have to do with if I have a current address, so I will move that down here. To do, look up function name at cur address. Is it at cur address? Or it's more like, it's not cur address that I want to show, is it? Yes, no, it is. It is. Yeah, oh, actually, that's weird. No, I always want to show the callee. Okay, this is just that weird thing about how we display stuff in GCC. We always want to show on the top of the stack the current address you're at. But when it comes to I don't know. Let me think. In the call stack, we want to be able to double click on them and go to the source location. For the top one, we want to go to where we are right now, right? But for every other one, we want to go to the callee location, so where we jumped into the current one. Yeah. So I think I'm going to need to do both here. I'm going to show the function address will be related to the call. Oh, it'll be related to the frame address. Look up function name of frame address. That's it. And set it here if found. That's good. Okay. So it's not really this, it's frame address that we want. So this can move back up. Yeah, that's it. Okay, let's see how this goes. Stop this. Okay, let's hit F5. A nice build time. Yeah, I'm still surprised that it builds pretty quickly considering how old my computer is. Vectrexy, let's attach that. All right, let's just see what happens. I'm gonna just hit F5. I just want to see. Okay, so here we go. Call stack. We are at 0x08d2, and here I have unknown source because this is being called. So I don't know, maybe I won't show this there, but basically this here is, I added this frame to my call stack, and that's actually like we call it the vector location. So when the Vectrex starts, what it does is it jumps to main, the main entry point, and that entry point is set in this memory mapped location at F000. That's how it knows where to go to, because main won't be at the same location for every program. So like basically the cartridge will set this, and then it'll say, jump here for main. So that's what you're seeing here. So let's do a little bit of stepping. Yeah, see when I do this, I'm back here. We have, right, we don't have the ability to step over, but we still have step into, so we'll do F11. And we can see that the address changed, which is good. F11, we go in there. And look, check that out. Check that out, guys. See, now we're at this address. This is so cool. And now we're going to enter this here. Set scale. So now look, if I click here and there, oh man, this is so awesome. We can actually traverse the call stack and see where we are. And I just noticed for the first time that the color is a little bit lighter. Like it's like a kind of a darker orangey yellow when this is the current actual PC location, and it's kind of sort of greenish when it's showing you when you're up the call stack, Yeah, this is super cool. Check that out. So yeah, so all I got to do really is, put function names here, resolve these locations to function names. And I almost wonder if I should just keep the addresses there. It's kind of nice to see them. It's because one thing about VS Code is we don't have like a disassembly view. There's no way to step into the disassembly, unfortunately. I really hope they add that eventually. It would be really helpful at times. So it might be useful here to like show, I think wait a minute, Visual Studio, they do show addresses, right? In the call stack, like if we just break here, call stack, what do? Oh, they put the line number, so we could do that as well, actually. And they don't actually show the address, but maybe if you do, is there like something we can do here? No. Okay, for some reason I imagine that they showed addresses here. Show external code. Okay, yeah, they'll do this. They will show the address when they can't resolve it to a name. This here is the module. We're not going to do that. But yeah, they show a full address. They actually put open close paren at the end to show that it's a function, and then they'll put like args and stuff. That's really, really nice. Maybe we could do that one day. But I like that they show the line number. We could do that. So okay, let's stop this quickly. Let's go see. We come back to our DAP debugger. So let's say we did something like this. Oh, and then the line number, it really depends if we have a line, right? So yeah, if we don't have one, we don't show one. So we could do this. Because if we want to do like them there, we could like put the parens. This here is a, yeah, it's just a regular string, right? So I could do something like this. Plus equals line oh wait, I could just use whatever, formatted string line %d hit F5. I think I should remove that attach thing. But anyways, whatever. Let's go back here. Okay, here we go. So now it says, it shows the parens and it says the line number that we're at. Pretty neat. 37. See, looking like Visual Studio now. So we see that here at line 37, line 80, and line 119. We can hit F9, F5, and then we can break with F6 somewhere. Is it F6? Pause? Yeah. Oh yeah, we're here. Oh, I think I hit an assertion. Yeah, it looks like I can mess up with the pause state. This is something I'm going to have to address. Anyways, I'm going to stop here, guys. This is really great. I'm very happy with this progress. We'll pick this up next week, where we will do the function name stuff here. Display the call stack as function names when available, or address otherwise. We'll do this. We'll say that's done. And we'll demangle the function names, all of that stuff. All right, so thanks again, guys, and I'll see you next time.